NASA just did something that sounds almost impossible to explain without making people mad. Artemis III, the mission many people thought would finally put American astronauts back on the moon, isn't going to land on the moon. No boots in lunar dust, no dramatic ladder moment, no One Giant Leap sequel with better cameras and worse Wi-Fi. Instead, Artemis III is now shaping up to be something way less glamorous, but maybe way more important. A high-stakes test flight in low Earth orbit, where NASA's Orion spacecraft will practice meeting up and docking with the commercial lunar landers that are supposed to make future moon landings possible. So, yeah, the headline sounds like a downgrade, but the real story is much more interesting. Because this isn't just NASA playing it safe. This is NASA quietly admitting that landing humans on the moon in the 2020s is not one giant mission. It's a brutal engineering relay race involving government rockets, private spacecraft, cryogenic fuel, orbital choreography, billionaire space companies, and a moon that remains extremely committed to being inconvenient. Before we drill into the space drama, do me a quick favor. Hit subscribe, tap like, and drop a comment telling me if you think NASA is being smart or stalling. It helps the algorithm remember we exist, which is basically the YouTube version of mission control not losing telemetry. Alright, so here's the thing. Most people imagine a moon landing like this. Rocket goes up, spaceship flies to the moon, astronauts land, plant a flag, take a few majestic steps, and boom, history. That's the Apollo version. Artemis is not that simple. Apollo was like taking a custom-built sports car on one legendary road trip. Artemis is more like building an entire airport, fuel depot, taxi fleet, navigation system, and rental car company, while already driving down the highway. For Artemis III to land on the moon, several things have to work together perfectly. First, NASA has to launch astronauts on the Space Launch System, or SLS, inside the Orion spacecraft. Then Orion has to head toward the moon, but Orion itself doesn't land. That's a huge detail. Orion is basically the deep space crew vehicle. It's the astronaut taxi between Earth and lunar orbit. To actually reach the surface, astronauts need a separate human landing system. And that's where SpaceX and Blue Origin enter the chat. SpaceX has Starship HLS, a lunar version of Starship designed to take astronauts from lunar orbit down to the surface and back up again. Blue Origin has Blue Moon Mark II, another lunar lander designed for crewed missions. On paper, this is the future. NASA handles the deep space architecture. Private companies build reusable or semi-reusable lunar transportation, and everybody gets to say the word sustainable at press conferences. But as always, physics is a party pooper. Landing on the moon is not just fly there and park. You have to launch massive hardware, transfer fuel, keep cryogenic propellants from boiling away, rendezvous in orbit, dock safely, support life inside the spacecraft, descend to a rough lunar surface, take off again, rendezvous again, and bring the crew home. That's not a mission. That's an orbital group project where every student is using a different spreadsheet. And NASA has learned this lesson the hard way before. Apollo didn't start with Apollo 11. Before Neil Armstrong ever stepped onto the moon, NASA flew Apollo 7 to test the command module in Earth orbit. Apollo 8 went around the moon without landing. Apollo 9 tested the lunar module in Earth orbit. Apollo 10 flew the lander near the lunar surface, almost like a full dress rehearsal. Apollo 11 only happened after NASA had worked through the terrifying little details that don't fit nicely on a poster. So, in a weird way, Artemis III becoming a docking and lander test in Earth orbit is not some ridiculous retreat. It's very Apollo 9. And Apollo 9 was not flashy. It didn't land anywhere. It didn't give the world that perfect TV moment. But without it, Apollo 11 would have been gambling with human lives. That's the core of the Artemis III reset. NASA needs to know that Orion can actually rendezvous and dock with these commercial landers before asking astronauts to do it near the moon, far from home, with no easy rescue option. Think of it like learning to connect two semi-trucks while they're both moving on a highway. Except the highway is space. The trucks cost billions, and the drivers are wearing pressure suits. Doing that in low Earth orbit is still dangerous and complex, but it's close enough that mission control has more options if something gets weird. And trust me, in spaceflight, something gets weird is not a possibility. It's a personality trait. Now, let's talk about the elephant in the launch pad. Why did this change happen? The simple answer is schedule reality. The Artemis program has always been ambitious. Maybe too ambitious. NASA wanted to return humans to the moon, use a giant rocket, develop Orion, coordinate with international partners, build lunar infrastructure, involve commercial landers, aim for the lunar South Pole, and eventually prepare for Mars. That's not a to-do list. That's a sci-fi franchise. And the lunar South Pole is not an easy destination. It's scientifically exciting because it may hold water ice in permanently shadowed regions. Water matters because you can use it for drinking, oxygen, and potentially rocket fuel. That's why every space agency suddenly acts like the moon's South Pole is beachfront property. But that region is also harsh. Lighting is weird. Shadows are extreme. Temperatures swing brutally. Communications can be tricky. Landing sites are more challenging than the smooth, flat parking lots engineers dream about. So when you combine that environment with brand new landers and a multi-vehicle mission plan, NASA has to ask a very uncomfortable question. Do we want the first crewed Artemis landing attempt to also be the first time some of these critical systems operate together with astronauts on board near the moon? That's the kind of question that makes engineers stare silently at a conference table, because the answer, if you care about the crew, is probably no. This is where the internet will split into two camps. Camp 1 will say, NASA failed. They promised a moon landing, and now they're not doing it. And honestly, that reaction makes sense. People were hyped. Artemis III had become the symbolic return of humans to the lunar surface. When the public hears moon mission, they expect moon walking. Camp 2 will say, this is smart. Test the system before risking the big mission. And that reaction also makes sense. Space doesn't care about branding. The moon doesn't care about deadlines. And rockets absolutely do not care what year is printed on a PowerPoint slide. The real answer is somewhere in the middle. Yes, this is a delay in the big emotional moment, but it's also a sign that Artemis has matured from a slogan into an actual engineering campaign. Because here's what makes Artemis different from Apollo. NASA isn't just trying to repeat history, it's trying to build a system. Apollo was about getting there first. Artemis is about being able to go back repeatedly. That's a much harder problem. If Apollo was a moonshot, Artemis is supposed to become a lunar supply chain, and supply chains are not cinematic. They're messy, expensive, and full of parts that arrive late. Just ask anyone who has ever ordered one missing screw from IKEA and suddenly understood the fragility of civilization. Now add rocket engines. The hidden danger in Artemis is not that NASA can't land on the moon. The danger is that the architecture becomes so complex that every delay multiplies across the whole program. If Starship HLS slips, Artemis slips. If Blue Moon needs more testing, Artemis slips. If Orion needs updates, Artemis slips. If ground systems, suits, life support, docking hardware, or mission software fall behind, Artemis slips. This is why Artemis III as a low Earth orbit test is more than a practice mission. It's a pressure test for the whole Artemis strategy. Can NASA coordinate government hardware with private spacecraft? Can commercial landers integrate safely with Orion? Can crews train for these new operations? Can mission control manage a multi-vehicle ballet without turning it into the world's most expensive traffic jam? That's what Artemis III has become, not the landing. The test that decides whether the landing architecture is real. And honestly, that might be the more important story. Because space exploration has a weird habit of making rehearsal look boring until history proves it was essential. Nobody makes blockbuster movies about docking tests, but every great mission depends on them. The first moon landing didn't happen because someone was brave enough to try. It happened because thousands of people were disciplined enough to test, fail, redesign, rehearse, and test again. That's the uncomfortable truth behind Artemis III. The moon landing got pushed back, but the mission may have gotten more honest. And in human spaceflight, honest is better than heroic, because heroes are great for posters, but checklists bring people home. So when Artemis III launches, don't think of it as the mission that failed to land on the moon. Think of it as the mission where NASA tries to prove the new moon machine can actually work. If it succeeds, Artemis IV gets a much better shot at delivering the moment everyone wants. Astronauts standing near the lunar South Pole, looking back at Earth, inside a program that can keep going, instead of just visiting once for nostalgia. And that's the bigger picture. Humanity's future in space won't be built by one perfect launch, one billionaire quote, or one viral render of a lunar base with suspiciously clean windows. It'll be built by awkward test flights, delayed hardware, boring docking trials, and engineers refusing to let hype outrun physics. Artemis III may not land on the moon, but it might be the mission that makes the next landing possible. Stay curious, fly smart,